Good evening, everybody. How you guys doing?
Good
Thank
evening,
you.
Professor. I'm doing well. I wanted
Very
to
good.
ask you really quick before class starts. For the
Go ahead.
Chapter 9 project, would so I did it all in MATLAB and I'm doing it by hand, but would I also need to do part 8 by hand as well?
What does part 8 say?
It's to produce a surface plot in MATLAB of a sphere with the radius and center of specific points.
No, do that only in MATLAB.
And then how do I send the MATLAB code to you?
You can copy it and paste it onto a Word document, a Google Doc.
Would a Word document or Google Doc would work for copying and pasting?
Either one is fine.
All right, thank you, Professor.
You're welcome. You guys, today we're going to do 9.2 and 9.3. So we are moving a little bit fast. 9.2 is all about vectors. Oh, one more thing. Chapter 9 homework is due September 17th, 8 p.m. I believe that's a Friday. Let me double check. September 17th, 8 p.m. Yeah, and I think that's a Friday. So that's the first homework assignment, Chapter 9. Hopefully you guys started it. Write that down in your calendars. Okay. 9.2 vectors. What is a vector?
You had said to average like 3 problems a class.
3 problems per section is what I meant.
Okay.
So today we're going to try to cover 2 sections, so 6 problems. But are you talking about the homework? That's what you meant?
Yeah, on the homework.
Yeah, if you can do 3 problems per class, you'll be almost on pace to finish the homework on time every time. But some classes we're going to do depending on how much of a section we finish. But the homework is like this. I give 3 problems per section on the homework. That's what I do. So the homework is heavy. There's a good amount of homework, but that's kind of to make up for the lack of exams and stuff. Um, a vector is an arrow that has length and direction. Okay, so let me see. Let me draw a vector. This is point A. This is point B. Let me draw another one. Let's do point C and point D. I'm going to call this vector U. I'm going to call this vector V. The vector U, actually, you can put like U like this. If you see that arrow hat notation, that means it's a vector. So U is the vector that goes from A to B. We can also say V is the vector that goes from C to D. If it goes from C to D, that means you put C first and then D first. So I'm showing you notation. I'm giving you a feel for how we describe vectors. There's a few ways you can draw vectors, or you can write out vectors, but let me see. A vector and a point in space, there's not much of a difference. Let's see. Let's see. This is the point right here, 3, 4. If I draw a vector from the origin to that point, that vector could be described in several ways. So I'm going to say 3, 4 is the point P, if we're going to describe a point. But if I'm going to describe a vector, I could say the vector P is 3, 4. You can use this notation. You can also say this is the x direction, this is the y direction. You can say the vector P is 3 in the x direction plus 4 in the y direction. And also, even more popular than that is if we say P, the vector P, is 3 in the I direction plus 4 in the J direction. So there's 3. I don't know why I wrote everything on the side like that. But there's 3 ways you can write a vector. I corresponds to x and j corresponds to y. So if you put that little caret hat, that means directional vector component. So you can see that a point in space and a vector are very similar. It's the same information. A vector preserves the direction, right 3, up 4, and the length, this length doesn't change. The length of that vector doesn't change. Are there any questions so far? No questions? Let me do this. Let me separate this. What if I did, what if I wanted to add vectors? The vector v plus the vector u. What would that look like visually? I'll show you. You take the vector v. Remember, the vector v, the position of the vector can change. You can translate it left, right, up, down. That doesn't matter. What matters is the direction stays the same and the length stays the same. So V kind of looks like this. It's about that big, that direction. So that's V. And then U is the other vector. Now you preserve the length and the direction, but when you add vectors, the second vector you put the tail at the head of V. So you kind of continue the direction. The arrows are always flowing. So U is approximately maybe like that. This is the vector U. So if you're going to add V plus U, you go from tail to head. And you get this vector. If I'm going to say V plus U equals the vector W, then this blue vector is W. That's how you add vectors. You take the first vector, you take the second vector, you put its tail on the previous head, and then you go from beginning to end. You make a triangle out of it. So remember, V, the vector V goes from C to D, which in this case is same as A, and U goes from A to B. So it's almost as if the vector W is the vector from C to B. I should probably be more careful. I'm only saying that for now, just to give you a feel for how it moves from point to point. Because I said you can translate vectors, that might not hold true for all these problems that we're going to do, but I'm just trying to give you a little intuition. Take 30 seconds to copy this down. Ask questions if you have any. Let me know if you're confused about vectors. In 30 seconds, I'm going to erase this. And we're going to go to a blank page. And I'm going to do another adding and subtracting vector example. So guys, let me know if you have any questions. Okay, let's do this. I'm going to draw an axis, X and Y axis. X, Y. What can I put? Let's have two vectors. Let's have vector Q and we're going to have vector R. let's say vector Q is let's say -2, -3, and R is -1, +4. So we got two vectors. Q, you can plot the point -2, -3. So -2 down 3, that's here. So the vector of that point looks like this. You always start at the origin. R is -1, 4. Let me do that in blue. -1, 4. That point is up here. So we have this vector, R. I want to do R plus Q. Let's see what that vector would look like if we did R plus Q. R is the red one. No, I'm sorry. Q is the red one. R is the blue one. So we have R, which is blue. If you add Q, what you do basically is you move that thing. So I'm actually going to move it. I'm going to move this. So you start with R, so it goes tail to head, and then the tail of Q goes there. Does that make sense? So Q should go down 2 and to the left 3 from where it was. I'm sorry, left 2 and down 3. So yeah. What is the position of the, so what would the resulting vector be? So we haven't finished. You got to connect from tail to head.
-3.
Yeah, -3 in the x direction, and then
1 in the y direction.
1 in the y direction. Very good. Yeah. I hope that makes sense. You know, we had Q is red, R is blue. If you're going to do R plus Q, you start with R. You take Q, put it at the end of R, and then finish that triangle. Yeah, and this is located at -3, 1. Now, you can also do it arithmetically. So we did it visually, and we got the resulting vector. You can do it like this. R plus Q. R is -1, 4 plus Q, which is -2, -3. You can go component by component. So it's going to be -1 plus -2 for the x components. And for the y component, it's going to be 4 plus -3. -1 minus 2 is -3. 4 minus 3 is 1. There you go. You can add vectors arithmetically, or you can visually line them up head to tail and then finish the triangle. Are there any questions about that? No questions? What if I did, could you do this one? What if I did Q, the vector Q minus the vector R? Could you figure out what that vector is? I'll give you a minute. See if you can do that one. So Hanin said -1, -7. You might be right. Let's see. Q is -2, -3, minus R, -1, 4. You're going to subtract component by component. So -2 minus -1 for the x, and -3 minus 4 for the y. -2 plus 1, -1. -3 minus 4, -7. So Q minus R should be -1 in the x direction, -7 in the y direction, which would look something like this. Let's see if I can. -1, -7, that would be way down here. I don't know if I can fit it, but sorry guys. My this thing is not working. Okay. It would be way down there. I mean, it's not going to be accurate visually. There's something wrong with this pencil thing. But let's see if I can prove it visually. I want to first let me do Q. Q is -2, -3, so Q is like here. And then R is -1, -4. -1. I'm sorry, -1, +4. So R is up here. That's no good. Come on, man, this thing. But we're not doing Q plus R. We're doing Q minus R. So what you do when it's minus R is you flip the arrow. So the arrow gets flipped. So that's the red arrow is not R, that's -R. So now if we're going to do Q minus R, that's the same thing as Q plus -R. So you go Q and then you add R to it and you get that. And you know, if I had drawn it correctly, the orange one, you see that it would line up perfectly. But I didn't. I didn't have my marks. But that's okay. Hopefully you see that it would have. So that means if I did -R, the vector -R, I'll put it right here. You just make the components negative. So instead of -1, it's +1. Instead of 4, it's -4. Are there any questions about this stuff? No questions? Take 30 seconds, copy down what you need to copy down. And then we're going to continue. I'm going to give you brief notes real quick, and then we'll start doing these practice problems. I gotta start moving a little faster, so forgive me. But please let me know if you have any questions. Okay, let's continue. Let me show you this. So let's say I use the other notation. Let me give you this vector. What's wrong with this thing? Here's a vector. It's 5 I hat minus 7 j hat. So before I did the arrow brackets. Now I'm switching it up. So what if I did 9 times the vector v? 9 times the vector v. That's 9 times 5 I hat minus 7 j hat. I is the x direction, j is the y direction. We could do three dimensionals, but it's okay. Two, I think you get the point with two. Then you distribute 9 times 5 I hat minus 9 times 7 j hat. 9 times 5 is 45 I hat minus 63 j hat. And that's the answer. So if you're going to multiply a vector by a scalar, you can just distribute the scalar to each component. Any questions about multiplication of vectors and scalars? In 9.3, we're going to talk about how to multiply vectors with vectors. But right now is just vectors with scalars. And then let me also show you the length of a vector. So length, this thing's not showing up. The length of a vector is also called the magnitude, which you can also say the norm. The norm of a vector is the same thing as the length or the magnitude. So, and this is how you do it. Some people say this. If you want the length of V, some people say this. Some people say this. They put 2 bars. It depends on which textbook you're looking at. I think the textbook that we use does one single bars. But what would this be? How do you find the length of this vector? It's just Pythagorean theorem. It's the square root of the first component squared plus the second component squared. What's 5 squared?
25.
Very good. What's negative 7 squared?
49.
What's 25 plus 49?
74.
74, 67. Yes, yeah, very good. What's the square root of 74? 8.4 or something? I don't know.
I got 8.6.
8.6. We'll leave it at 8.6. Thank you.
Yeah, 8 point.
So, if you graph that vector, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, and you wanted to know how long that vector was, the answer is the square root of 74. That vector has length square root of 74, or magnitude or norm. Whatever you want to use is fine with me. Doesn't matter. Take 30 seconds to write this down. and then we're going to practice. We're going to start with problem 18 out of the textbook. Let me double check something. Cool. I have to teach you one more thing. I have to teach you one more thing. I can actually fit it down here. And I'll put it in blue. The unit vector. I'll type it out actually. Unit vector of v hat equals equals a vector with the same direction as v, but with length equal to 1. So this is called the unit vector. And if you want to know how to get this unit vector, I'm going to call it the unit vector of v. That's what I'm going to call it. You take the vector v and you divide by the length of v. So copy that down. So if I'm going to draw it in blue, the unit vector on v is going to be in the same direction, but it's going to have length 1. Why is that useful? Because if you can make the same vector but shrink the length down to 1, then you have a vector that you can, if you want it 100, you just multiply by 100. If you want it length 12, you just multiply it by 12. It's just easy to operate with. You kind of normalize. So that's what I drew in blue. It's the same vector as the red, but it's shrunk length 1. So you take the vector v and you divide it by its length, you get the unit vector. Take 30 seconds to copy that down. Let's move a little quick. Let me show you the problem, and I'm going to give you 5 minutes to do it. See if you can move a little quick. I want you guys to do 18. Five minutes. So 5:46 p.m. Do 18. See what you can do. They didn't use the arrow notation. Sometimes in the textbook, when they tell you it's a vector, they make it bold. So for 18, you have 2 vectors, A and B. See what you can do. See if you can do 18. I'll be right back. All right, guys, let's work on 18. This is problem 18. They gave us two vectors, okay? They didn't use the notation that we use. They used bold lettering. So let's call it vector A and vector B. Vector A is 2I hat minus 4J hat plus 4K hat. Now, if I and J are X and Y, you can imagine what K is. K is in the Z direction. So now this is a three-dimensional vector. X, Y, Z, I, J, K. B, they don't give you an I hat. So if they don't give you an I direction, that means the coefficient is 0. Plus 2J hat minus K hat, which means minus 1K hat. I hope you guys were able to fill in the blanks. Any questions so far?
No.
So part A, let's see. They do, what is A plus B? Okay. A plus B is, you can add up the components, right? You can add these, you can add these, you can add these. Component by component is going to be 2 plus 0 I hat plus negative 4 plus 2 J hat plus 4 minus 1 K hat. So the answer is 2 I hat.
Negative 2J hat and 3K hat.
Very good. Thank you. Plus 3K hat. Yeah. And that is A plus B. Hopefully you were able to get that one. If you have any questions, please let me know. If not, let's do the next one. 2A plus 3B. 2A hat plus 3B hat. I mean B vector. I don't know why I said hat. 2 times the A vector is 2 times 2I hat minus 4J hat plus 4K hat. Plus 3 times the B vector, 0I hat plus 2J hat minus 1K hat. Now I understand why they invented the other notation with the arrow brackets, because this is annoying. I have to write I, J, K. But whatever. Let's distribute. So each coefficient you distribute here, and you're going to distribute the 3 to each component. You're going to get 4 I hat minus 8J hat plus 8K hat plus 0 I hat plus 6J hat minus 3K hat. And if you continue, the i's go together, right? the j's go together, and the k's go together. So 4 plus 0 is 4. Negative 8 plus 6 is negative 2. 8 minus 3 is 5. And that's that. 2a vector plus 3b vector is that 4i minus 2j plus 5k. Any questions about that? No questions. The next one is the magnitude of A. So how long is the A vector? The magnitude of A is, you're basically doing Pythagorean theorem. So the square root of the A components squared. So 2 squared plus negative 4 squared plus 4 squared. That's the square root of 4 plus 16 plus 16.
Which gives you the square root of 36.
Square root of 36 is what? What's the
The
square root of
square
36?
root of 36 is 6.
Yeah, 6. So square root, it could be plus or minus 6, but which one is it? Is it plus 6 or is it minus 6?
It's an absolute value, so it's positive.
Yeah. It's positive 6 because this is length. Length is always non-negative. You can't have negative length. Excellent. 6 is the answer. All right, next one is the magnitude of A minus B. All right. Let's see if I can fit it. The magnitude of A vector minus B vector. That's the magnitude of 2i hat minus 4j hat plus 4k hat minus the b vector 0i hat plus 2j hat minus 1k hat. So the magnitude of that, well, that's the magnitude of 2 minus 0 is 2. Negative 4 minus 2 is negative 6. 4 minus negative 1, 4 plus 1 is 5. So you do the square root of each component squared, and you add them up. 2 squared plus negative 6 squared plus 5 squared. I'm sorry for being sloppy. I'm going to continue up here in blue. Let me continue up here. The square root of 4 plus 36 plus 25. 40 plus 25 is 65, which is close to 8. But square root of 65 is good. So if you're going to do vector A minus vector B and you want the length, the answer is the square root of 65. Are there any questions about that one? If there's no questions, take 30 seconds to copy that down. And then we're going to do 20. Okay. All right, I'm gonna change the screen. Let's do 20. Let me see. Everybody do 20. I'm gonna give you 5 minutes. I'm gonna give you 3 minutes. So 6 p.m. Excuse me. Do that. Let's see. Okay, guys, number 20. Let's do it. They want you to find the unit vector. Okay. So this is 20. Let's say we're given this vector. I don't think they gave it a name. We'll just call it V. V is -4 in the x direction, 2 in the y direction, 4 in the z direction. the unit vector of V. If you remember the formula, it's the vector V divided by the magnitude of V. If you don't feel comfortable with division of a scalar and a vector, you can think of it as 1 over the magnitude of V times the vector V. So let's start with the magnitude of V. Let's start with that. The magnitude of V, doing Pythagorean theorem. So you take each component and you square it. 2 squared, 4 squared. And you take the square root of that. 16 plus 4 plus 16. Look at that, how convenient. Square root of 36, 6. So if I were to continue here, the magnitude of the vector V is 6. That's how long that vector is. 1 over the magnitude of V, which is 1 over 6, times the vector V, which is negative 4, 2, and 4. So what do? When you multiply by a scalar like 1/6, you just distribute. So this 1/6 is just going to distribute, distribute, distribute. I'm going to put the answer up here. You get negative 4 over 6, 2 over 6, and 4 over 6. If you want to simplify, negative 2/3, 1/3, 2/3. That is the unit vector of V. So that means if you graph V, I don't know what V looks like. Let's just say V is like this. Then the unit vector, so this is V. The unit vector of V is going to be in the same direction. But has length 1. So it's shorter. I don't know if it's, yeah, it should be short. Yeah, it's shorter. It's going to be 1/6 the length, right? This is length 1. And the vector V has length 6. Any questions about number 20? Take 30 seconds to copy this down. Please ask questions if you have any. If there's no questions, let's work on number 22. So let me do that. So I'm going to say work on, do 22. I'm going to give you 5 minutes. So that's 6:11 p.m.
Nothing but positive trials, even if the opposition wants to say they're low quality and small, which they're not. Precautionary principle would tell you to recommend it. But here's another more clear example of abnormal behavior. The two other parasitic diseases for which ivermectin was approved as the standard of care worldwide, 10 trials with 852 patients. Right now, ivermectin is sitting on 24 randomized controlled trials with 3,000 patients, and it's not being recommended. They're the results, just published by Andrew Bryan, Tess Laurie, Scott Mitchell, actually, who's a member of the FLCCC. But this is a group of researchers who, for decades,
All right, guys. 22, right? Let me change the name. Let's call it P. This is 22. The vector P is -2 in the x direction, 4 in the y direction, 2 in the z direction. They said they want the same vector to achieve this. Any suggestions?
We can find the unit vector that multiplied by 6.
Very good. Find the unit vector of P and then multiply that by 6. Because the unit vector of P will have length 1. Excellent. Okay. So let's find the unit vector of P. Let's do that. The unit vector of P is going to be the vector P divided by the length of P. All right, so then let's find the length of P. It's the square root of each component squared and then added. Four plus 16 plus 4. Square root of 24. It's the, what goes into 24? Square root of 4 times 6. 2 root 6. The length of P is 2 root 6. Okay, if I continue here, P is -2, 4, 2. The length of P is 2 root 6. So if I'm going to divide, that's like multiplying by 1 over 2 root 6. I can just distribute that 2 root 6 to all three components. And you get something like -2 over 2 root 6, 4 over 2 root 6, 2 over 2 root 6. And if you want to simplify, that's -1 over root 6. 2 over root 6 and 1 over root 6 in the z. We're not quite done. We put the final answer in red. So we got the unit vector. We got the unit vector. But we're supposed to get the unit vector and then multiply by 6. So it's going to be 6 times all this stuff. I hope this is not sloppy. I hope you can follow along. I know I'm all over the place. And then if you continue, distribute that 6, you just get -6 over root 6, 12 over root 6, 6 over root 6. And that's it. This vector and the vector p, they go in the same direction, but the red vector has length 6. That's the only difference. The vector p has length 2 root 6. Are there any questions about 22? No questions? Okay. Let's see. Give me a second. Sorry. Take 30 seconds to copy this down. Ask questions if you have any. And then we're going to start on 9.3, the dot product. So take 30 seconds to copy this down. Okay, let's discuss the dot product. So this is 9.3. We're going to be doing problems 19, 24, 27. If you have a vector, let me see. So you got this vector. Let's say you got this vector. This is B. This is A. If you translate them so that they're touching, you're going to get this. You're going to get A. And then you're going to get B. If you go tail to tail, so, a vector maintains length and direction, but you can move it around. This is still B. We just moved it. We went tail to tail. The question is, what is this angle, theta? You can find the angle theta, and this has to do with multiplication of vectors. The dot product is how you multiply vectors. A, it's called, let me see, A dot B is the magnitude of A times the magnitude of B times cosine of theta. So this is one form of the dot product. The other form of the dot product is the sum. You take each component of A times each component of B. You multiply them and then you add them. And I'll show you what that means. Don't be intimidated by the sum notation. I mean, you guys took Calc 2. You should know what that means. But I'll show you. Should be an I. Yeah. So let me ask you something. What happens if A is perpendicular to B? You know? What happens to the angle? If A is perpendicular to B, what is the angle?
90 degrees.
90 degrees. Okay, so this is a right angle, right? What's wrong with this thing? So if I put 90 degrees in for theta, what is the dot product gonna be?
0.
Let's see. Yes. Yeah. So let me see this. If I do A dot B, that means the angle is 90. So cosine of 90 is 0. So everything becomes 0. It's the magnitude of A times the magnitude of B times 0, which is just 0. So if you have two vectors and they're perpendicular, the dot product is 0. Okay, what about this? What if B and A are parallel? What is the angle between parallel vectors? If this is 90, what is this?
180.
What's that? You can
0.
say 180, you can say 0 or 180, right? 0 or 180. I think if it were 180, the arrow would go this way, but it doesn't matter. It's not a big deal. Okay, so what happens if I plug in 180 in for theta?
It would be -1.
Let me see. Let me not go with 180. Let me just go with 0 for now. Let me go with 0. So what if I plug in 0 for the angle? What's cosine of 0?
1.
1. So cosine of 0 is 1. So if the vectors are parallel and you do A dot B, it's just the same thing as the length of A times the length of B. So if they're perpendicular, the dot product is 0. If they're parallel, the dot product is just the length times the other length. Let me give you some vocabulary real quick. Perpendicular is the same thing as orthogonal. It's the same thing as normal, which is 90 degrees, which is a right angle, which is pi over 2 radians. Everything I said is the same thing. And the symbol for perpendicular is this. If you see that symbol, it means two things are perpendicular. In the textbook, they like to say orthogonal. I don't know why. That's just the words they choose. So every time you see orthogonal, the same thing as perpendicular. Okay, so I still haven't explained this. And I'm going to do that. I haven't explained this. I'm going to do that on the next page. But take 30 seconds, copy down this stuff, and then I'm going to move to the next page. I'll give you an example. All right, let me show you this thing. Let's do this. I said that if you do the dot product of two vectors, you can do this if you want. But that means in order to do the dot product, you have to know the angle between the vectors. You want to do trigonometry? Probably it's the same thing as the sum. You multiply each component. You add them up, you take the sum. So what does that mean? Let's do an example. A is, let's switch up the notation. 2 in the x direction minus 3 in the y direction plus 4 in the z direction. And B is going to be this vector. 9x hat, 7y hat minus 5z hat. So if I'm going to do A dot B, you're going to multiply each component. So you're going to multiply these, multiply these, multiply these. 18, and this is negative 21, and this is negative 20. And then you add them. 18 minus 21 is negative 3. Minus 20 is negative 23. And that's it. The dot product of A and B is negative 23. So if you dot two vectors, you get one scalar. This is one way of multiplying vectors. Are there any questions about the dot product? So let me ask you, A and B, are they perpendicular? Are those vectors perpendicular? Nobody knows? Does this equal 0? No.
No.
So not perpendicular. Those two vectors A and B are not perpendicular. Any questions about this style of the dot product? Please let me know. Take 30 seconds, copy this down, and then we're going to work on problem 19 in the textbook. 9.3. These ones, they're a little tricky. I think you can do them. Just think, draw a picture if you have to. But yeah, try that. So here, let me show you. This is 19. Work on this one. Do 19. I'll give you 6 minutes. See what you can do. So that's 6:40 p.m. But work on 19, everybody. You guys, do you guys have trouble with this one? It's a little bit difficult. I'm going to show you how to think about it. They want the angle between each, the angle at each vertex. So that means there's three vectors and the angle between each pair of vectors. So let me show you how to think about this. This is 19 that we're working on. Before we get into the details of the problem, let's talk about our approach. So we know that the dot product of two vectors is you can add up the multiplied components and you can also do the length times the other length times cosine of the angle. If you remember the problem statement, they want the angle. So if we're looking at this and you want the angle, you could say that the sum of the multiplied components divided by length times length equals cosine of theta. So if you want the angle, you can do cosine inverse of both sides and this will give you the angle. Does that make sense? I hope that makes sense. If you want the angle between two vectors, you can use this formula. And that means we have to figure out what these vectors are. Because we weren't given vectors, we were given points in space. So given the points, you draw a triangle, then you have to extract from that the three vectors. So take a second to write this down. Actually, I'm going to continue over here. I'm going to draw this thing. It goes to 6. So let's say 2, 3, 5, 6. So if you read the instructions, there's a point at 1, 0. There's a point at 3, 6. There's a point at -1, 4. You connect the dots and you have your triangle. Okay, but those coordinates are not the same as the vector. That's 1, 0. This is 3, 6. This is -1, 4. You can, those are points. Those are not the vectors, okay? So let's put some arrows on these things. Maybe there's an arrow here. It goes this way. It doesn't really matter. And then arrows going like this for this one. Let's call this one, let's call these, this is going to be vector D, vector E, vector F. Just by looking at it, can you tell me what is D, E, and F? You know, you start at the tail, you go to the head. How many do you go in the X direction? How many do you go in the Y direction for D?
2 comma -4.
Yeah, for D is going to go 2, 1, 2, down 4. So the vector D is 2, -4. What about E? What would the vector for E be?
4, +2.
Yeah, E goes 1, 2, 3, 4, and then it goes up 2. So E goes 4 in the X direction, 2 in the Y direction. And then F, the vector F, how much in the X, how much in the Y?
2 in the X, 6 in the Y.
Very good, 2, comma 6. Because F from tail to head goes 1, 2, and then it goes up 6. Look at that, I screwed it up. 2, comma 6. Okay. Give me this now. Now give me the length of each. I want you guys to do this. Take a few seconds. Tell me the length of each vector. When you have the answer, just shout it out.
So for D, it's 2√5.
2√5. Let me make sure. That's 4. That's 16. The square root of 20 is 2√5. Very good. Very good. How about E? What's the length of E?
I got 2√5 again.
Yeah, that's right. And F.
2√10.
Sorry, 2 squared plus 6 squared. 4 plus 36. Square root of 40. 2√10.
Yes.
Yeah. Are there any questions? I know I did that very fast, but let me write that down. Two root 5. 2√5. Any questions? We have the vectors and we have the magnitudes. Marcus, do you have a question?
Yeah, so for the coordinates on the right, like 2, -4, 4, 2, 2, 6, I see how you got them, but like, why is it that you picked like the further left point to do them, and afterwards you did like the bottom point to find F?
To
I don't know if
find
you get what
F?
I'm asking. So like to get D, right?
Yeah.
I guess you started from like from the left point, like -1, 4, right?
Yeah, the tail.
Yeah, and then you went 2 down 4, so that's how you got that one. Then E, you went to the right 4 up 2, but then F, why did you do the bottom one?
So F goes like this. This is the tail, and this is the head of
Oh,
F.
right, okay.
But it
Okay.
doesn't matter. If you change the direction of F, this angle stays the same. It doesn't
Okay,
matter.
yeah. All right, thank you.
No problem. Okay, I hope you have this written down, guys, because I'm gonna erase and I'm gonna continue on the next page. This is a long problem. It's not that short. Um, any other questions so far? No other questions. Okay, let me continue. So this is still problem. What are we doing? This is problem. What is this? 22? This is problem 19. Sorry. No, we got the vectors. D, E, F. And we got the magnitudes. The vector D is 2, -4. And the magnitude is 2 root 5. The vector E is 4, 4 and 2. 2 root 5. And then vector F is 2 and 6. 2 root 10. So remember, theta is cosine inverse of this thing over the lengths multiplied. I did one bar here and I did 2 over here. It doesn't matter. It's the same thing. So let's do let's do the angle between D and E. The angle between D and E is cosine inverse of D D dot E. That's going to be 2 times 4 plus -4 times 2. Please let me know if that doesn't make sense. I'm doing the component dot product of D and E. So 2 times 4, -4 times 2, and you add them. Length of D is 2 root 5. The length of E is 2 root 5. So the angle between D and E is cosine inverse. On the top is 0, right? 8 minus 8 is 0 over 4 times 5, which is 20. The cosine inverse of 0. What's the cosine inverse of 0?
90.
90 degrees. When cosine is 0, the x coordinate is 0. Yeah, 90. So the angle between D and E is 90 degrees.
So the sum AI BI is just the dot product of A and B.
Correct. Correct.
So that whole formula can also be written as like A dot B over the magnitude of A times the magnitude of B.
Yes. Yeah. I wrote it like this so that you know which specific dot product to do.
Okay, so like components times components
Yeah.
instead of the whole cosine.
Yeah. That's correct. So let me do the angle between E and F. Let's try that one. The angle between E and F. This is a long problem. Wasting so much time. All right, E and F is cosine inverse of, if you're going to dot E and F, you're going to multiply 4 and 2. Okay. You're going to multiply 2 and 6. And add them. And you're going to divide by the length of E times the length of F, 2 root 10. Cosine inverse of 8 plus 12 is 20. 4 times the square root of 50, which is 4. The square root of 50 is 5 root 2. So that's the cosine inverse of 20 over 20 root 2. The cosine inverse of 1 over the square root of 2. That's the same thing as the cosine inverse of the square root of 2 over 2. What angle gives you cosine square root of 2 over 2?
45.
Very good. I hope your trigonometry is good enough to follow that. Again, 2 root 5 times 2 root 10, that's 4 root 50. Root 50 is 5 root 2. So you're just going to end up with 4 times 5 root 2. That's, you get a 20 over 20. Those cancel. 1 over the square root of 2 is the same thing as square root of 2 over 2. If you remember your unit circle, when cosine is root 2 over 2, that's 45 degrees. Okay, you got a triangle with 90 degrees and 45 degrees. What's the last angle?
45 degrees.
Very good. The angle between D and F is 45 degrees. Why? Why is that?
Because it's a 45, 45, 9.
Yeah,
It adds up to 180.
it adds up to 180. You take this angle and this angle and this angle, it should add up to 180. And that's it. That's the end of the problem. So when they give you coordinate points, that's not the same as the vector. So if you have to draw the points and then figure out the vector, how much do I go x? How much do I go y? And then you give yourself 3 vectors, get each magnitude, and then use the formula for each pair. And that's it. That's the end of the problem. Any questions about this stuff? This was a little difficult. It's not that easy. take 30 seconds to copy and to ask questions. And then I want you guys to do 24. 24 shouldn't be as difficult, I don't think. But let me know if you have any questions. All right, guys, let me show you 24. I want to give you a few minutes. 24 should be a lot shorter. So it's a little bit easier, I think. I could be wrong. So I want you to do 24. I'm going to give you 5 minutes at 7:07 p.m. We'll work on that.
Professor, I had a quick question.
Yeah, go ahead.
On the previous one, after I did D and E, I did D and F instead of E and F. And my final one was inverse cosine of negative root 2 over 2, which is like on the other end, which would be like more than 180 when you add it up.
Let me see. I'm thinking. Well, you have to do a little analysis of the triangle. You know that the angle has to be less than 90, correct? Because it's a
Yeah,
triangle. And we
yeah.
already have a 90, so this next angle has to be less than 90. So you have to kind of recognize if it says negative root 2 over 2, you can kind of just flip it across and do positive root 2 over 2.
Okay.
So the formula is not all that it's not all that absolute. You have to analyze trigonometrically what you're looking at as well. Okay, it's 7:07. Let me write this down. This is -2. All right, let's do 24. This class ends at 7:15, right? Do I have that right?
Yes.
All right, cool. They said, somebody answer me. What does orthogonal mean?
It means
Perpendicular.
perpendicular.
Yeah, it's like perpendicular in 3D space.
Very good. Orthogonal means perpendicular. Okay, what does that have to do with the dot product?
You can use the dot product to find the degrees, and then using the degrees, it is orthogonal if the degrees is 90 degrees. It's parallel if it's 0 or 180 degrees. Anything else
That's,
is neither.
that's correct. And 90 degrees on the dot product means the dot product is 0, correct?
Yes.
Okay, so then we're going to take the dot product and we're going to set it equal to 0 and solve. If you take the dot product and you get 0, then they are orthogonal, perpendicular. Okay, help me out. Start the dot product for me. Tell me what to do.
-6b plus
Good.
b cubed plus 2b is equals to 0.
Very good.
Then you can factor out a b.
Let's simplify. B cubed minus 4b equals 0. You said factor out a b,
Yeah.
so you get b squared minus 4 equals 0. Can I factor any further?
You can do b plus 2, b minus 2.
Very good. That's a difference of squares, so this is b plus 2, b minus 2. There are 3 b's that will give me 0. What are they?
0, 2, and -2.
B equals 0, b equals 2, b equals -2. And that's it. Any questions? Any questions about that one? If they say orthogonal, that means the dot product should be 0. So set it equal to 0, do the dot product. After that is algebra. You got a cubic, factor. You got a difference of squares, factor. You should be able to factor polynomials. And any questions on 24? That's the answer, 0, 2, and -2. No questions? Let me see. What was I gonna do next? I was gonna do 27.
Oh, but 0
Yeah.
wouldn't make a vector.
0 wouldn't make a vector. Why do you say that?
You're taking two vectors and taking the dot product, and you're trying to find two vectors that would be orthogonal to each other. But if b equals 0, it'd be -6i,
Yeah,
2k, dotted with nothing.
you're right. It's not nothing. It's still a vector, but you're right. Those would be zeros. So yeah, you know what? Yeah, that vector has like almost no direction. So you're right. we can't use that. The other two we can use. Yeah, you're right. Because if you get this zero vector, it's, yeah, it's kind of like there's no direction or magnitude. It's just, I guess it's like a dot or whatever. Yeah, you're right. Thank you for pointing that out. Any other questions, comments on number 24? Look, we got 3 minutes left. It's not enough time to do the next problem. I was going to do 27 in the textbook. Um, I can show it to you, but I think that's it for today. We don't have to do that one. If you want to, you can do 27. But for 27, you have essentially is going to be the first vector. I'll type it in the chat. Is 2, -1. And the second vector is 3, 1. So if you're looking at number 27, there's the single number 3 and there's a single number 7. You can ignore those. You're looking at two straight lines. 3 and 7 kind of dictate the y-intercept, but that doesn't matter because the lines go on forever, so they're going to cross at the same angle regardless of where they're shifted. So you just take the coefficients of x and y, and that becomes your vector. So you got two vectors, you dot those, do the cosine inverse, you can get the angles. But you can 20 if you like, but that's it for today, guys. I should say one more thing. I'll put it in the chat, okay? Chapter 9 project, they're due at the same time. So chapter 9 project and chapter 9 homework. Whenever we finish a chapter, you have the homework and the project due at the same time. So if you go to Blackboard and you go to materials, I put the first two projects and I'm going to write the rest soon. So you can look at project 9 if you like. And I haven't taught you any MATLAB yet, but that's okay. I'll get to it. Don't worry. But that's it for today, guys. Thank you.
Our next class is on Wednesday, right? Next.
I think you're right. Hold on. What is that? Labor Day is Monday?
Yes, Labor
I
Day
think
is
you're
next
right. Let me
Monday.
double check. Okay, Labor Day is Monday, so I'll see you guys in a week. No class on Monday, guys.
All right, thank you.
Yeah.
Okay, thank you.
Thank you.
Thank you,
Professor,
Professor.
I
You're
have
welcome.
finished, Professor.
See you guys Wednesday.
Professor,
Yeah.
I have finished my Chapter 9 project. I just sent it to you via email. Would it be alright if you took a look at it and you see if I made like any mistakes?
Sure. Did you send it to my Gmail?
No, I sent it to your Montgomery College email. That's my mistake.
That's okay. That's not a problem. If you could send it to my Gmail, I'd appreciate it.
Yes, so let me go on to Gmail.
Okay, Professor. Have a good day.
All right, Saleh, take care. Joe, did you have a question?